Previously we looked at ABC and we saw there are 6 ways to arrange them. So let us look at A alone. How many ways do you have to arrange A? Well, it's just one way, just A. And this is just the number 1. What about if you have AB? And remember, the order matters now. We're dealing with permutation. How many permutations are there of AB? Well, you could have AB, or you could have BA. Anything else? Well, this looks like that's it. So you have 2 ways. And since there are 2 letters here, you could see if the factorial would work for this. 2 factorial is equal to 2 by 1, which is 2. 1 factorial is just equal to 1. The factorial seem to be working. Remember the ABC? For the ABC, we're looking at how many ways we can arrange ABC. We could start with A, then B, C, start again with A, then C, B. Alright? We finish starting with A. There's no more arrangement starting with A. So let's start with B. We could have BA and then C. We could have BC and then A. We started with B here. And we saw that there are 2 ways that you could place them starting with B. We can start with C next. Suppose we start with C. You could have C A or C B. There's no more letter. Alright, so if we have C A, then we have B, and if we have C B, then we have A. So here we have 6 arrangements of these 3 letters. There are 3 letters there, and if we calculate 3 factorial, we get 3 by 2 by 1, which is 6. Wow. So, doing this, we see that we could have the number of letters factorial to see the number of ways that we could arrange them. Suppose you had 4 letters. Would it work? Let's erase these and see. If you have A, B, C, D, let's write our A, B, C further up top in case we need a space. If we have A, B, C, D, by our previous argument, the number of ways are the number of permutations, which is the number of ways you can arrange them where the order matters, would be 4 factorial, which would be the same as 4 by 3 by 2 by 1, which is 4 3 is 12, 12 2 is 24. Well, that would be quite a bit. But let's see if we can go ahead with it. We're starting with A. A. Now, if we put the other letters in alphabetical order, we could have the next one as B, or if we start with A, we could have the second letter as C, or if we start with A, we could have the second letter as D. Alright. Now, we have AB. Now the thing is, let me put some space between these. We could have AB, then C, and D. So that's one permutation. We could have AB and then DC. That's the other. Now, we start with A and we have B next. There is nothing more that we can write starting with A and B because we've run out of letters. So let's start with A and then C. Now this is what we are arranging. We have 2 ABs, So I think we're going to have two ACs here. We can have AC BD, or we could have AC DB. We can't use one letter two times, so we've run out of letters. We have AC, and then we have BD and DB. That's it. Now, that's 1, 2, 3, 4 of them gone so far. All right. Let me put a line here to mark them. That's 4 arrangements so far. Starting with A. We can continue starting with A by saying A, and then the next letter, the second letter was B. Then we had started with A and then C. Let's start with A and then C. A, B, D, I mean D. I expect 2 ADs to be here. So it's A, D. AD, and then you have BC and AD, CB. So that's 5, 6. All right. We have that so far. So we started with A. Is there any other arrangement where we could start with A? Well, we start with A then B, then we did A then C, then we did A then D. So we have run out of arrangement starting with A. Let's start with B now then. Start with B. We have BA, and then we could do BA, CD. We could also do BA, DC. Good. Starting with B. Again, we've done BA already. Let's try BC. I think we're going to have 2 BC. So let's write them down from now. We have BC, AD, and then BC, DA. Good. Let's start with B again. We'll have 2 of them. We have BA already. We have BCs already. Now BDs. I guess we're going to have 2 BDs. Now we have BD, AC, and BD, CA. Is there any other? Starting with B. We seem to be running out. We have run out of B's. Starting with B's. So this would be 7, 8, 9, 10, 11, 12. Okay. Now, let us continue where we're going to start with C. So we have CA. We should have 2 CAs based on what happened before. We have CA and then BD, CA, DB. Good. We start with C again, and the second letter is B. So we have CBs now. CB, AD, and CB, DA. Okay. Now, let's start with C again. We have CA already, CB. We can't do CC because we can't repeat letters, so we use CD. CD now. Now, if we do CD, one of the CDs would be CDAB and the other would be CDBA. Is there any other arrangement where we start with C? We had CA, CB, CD. There's no more letter. You don't have an E, so you can't say CE. So we've run out. So here now, we have the numbers would be 12, this is 13, 14, 15, 16, 17, 18. All right, let's continue. We should reach 24 at some point. Suppose we have an arrangement where we started with A already, we started with B, we started with C. Let's start with D now. So we have DA. We should have 2 DAs. So we have DA BC and DACB. Okay. Now we start with D again. This time DB. We should have 2 DBs. DB, then we have AC and DBCA. Okay, good. Now let's start with D again, And this time the second letter is C. And we should have two DCs. Let's see what happens now. If we have DC, we could have DCAB and DCBA. So these come up to 19, 20, 21, 22, 23, 24. Is it really 24? Alright, let's see what other combination or what other permutation we have. Oh, there's no more now. So these are showing evidence that when you have a certain number of items to arrange and the order matters, the number of arrangements you can have would be the number factorial. That number factorial. Now remember, this is only one combination because the combination only thinks about them being there. It doesn't matter the order in which they are there. So this is just one combination. But there are 24 permutations. The order matters. Alright, we'll continue looking at this topic in another video. So I'll see you then.